Well, let's solve logarithmic equations, this time where we've got logs on both sides. And as I mentioned at the end of the previous video, I'm going to emphasize it again, that I have to double check my answer to make sure that I'm not going to end up trying to take the log of a negative number. You know why? I can't take the log of a negative number, which probably is a pretty good clue that this may come up in this example. So let's see what we start off with here. We got log base 3 of x squared minus 15 equals log base 3 of 2x. Well, fortunately, on both sides of the equality, I have the same log base, and that being the case, those could just cancel. So I can cancel those out, and then I can just deal with that x squared minus 15 equals 2x. Well, this looks just like the beginnings of a quadratic equation, which we can solve. And of course, I want to subtract the 2x from both sides. And then when I do, and I'm going to write it in, I think it's standard form, general form, we end up with x squared minus 2x minus 15 equals 0. Well, this looks like something I can factor. And then when I factor, I can then solve each piece of each factor, place it equal to 0 and solve for x. Well, let's factor this. And I look here and I see that this is negative and this is negative. Well, the fact that this is negative tells me I'm going to have a plus and a minus in each of my factors. One's going to be a positive, one's going to be a negative. And the negative needs to be larger. I need two numbers that are going to multiply to negative 15 and then add to negative 2. And my solution then is x minus 5, one factor, second factor, x plus 3. And we still got those equaling 0 at this point. So let's see, negative 5 times 3 is negative 15, and negative 5 plus 3 is negative 2. We've accurately factored that quadratic equation. Well, now let's set each factor equal to 0. We'll start with the x minus 5. X minus 5 equals 0. We add 5 to both sides, and x is equal to 5. And we'll take the second factor, x plus 3 equals 0. Subtract 3 from both sides, and we got x equals negative 3. And this is where I've got to go back in, and I've got to look back to my original equation, in this case, and determine, are either one of these possible answers going to cause me to try to take the log of a negative number, which I can't do. Well, let's put the 5 in here. So if I put 5x squared, 5 squared minus 15 into that, well, 5 squared is 25 minus 15, that equals 10. No problem there. And I also need to substitute 5 in the 2x. Well, 2 times 5 also equals 10. How about that? Log base 3 of 10, log base 3 of 10. Those do equal, don't they? It's also a good check. So 5 is a valid solution. What about the negative 3? Well, if I put the negative 3 in for x and square it, I've got 9. Well, 9 minus 15 is negative 6. I can't take the log of base 3 of negative 6. And also, just, I guess for redundancy, if I took 2 on the 2x and substituted in negative 3, I also would get negative 6. But again, we can't take the log of a negative number. So negative 3 is not a valid solution, leaving me with only one solution, and that is x equals 5. Be careful that your possible solutions don't cause a constraint that you can't overcome, which in this case is trying to take the log of a negative number.